Hi friends, this is first part of lecture number 25 and today we are going to start one phase full wave controlled rectifier with RLE or RL load. In this lecture we will study circuit operation and waveforms. To simplify the circuit operation, load is assumed highly inductive. When load is highly inductive, then we can assume output current nearly constant. Now see this circuit. It has 4 thyristors T1, T2, T3 and T4. Source voltage is Vs and this source voltage is connected between point A and B with polarity as shown here. So we can write VAB is equals to VA minus VB, that is equals to Vm sin omega t. If VAB is Vm sin omega t, then VBA will be obviously minus Vm sin omega t. See the waveform. Here dark blue line is for VAB and dotted line shows VBA. We will study the circuit operation in two angular modes. First from alpha to pi plus alpha, then from pi plus alpha to 2 pi plus alpha. First see the operation from alpha to pi plus alpha. At omega t is equals to alpha, thyristor T1 and T2 are triggered. If we look at the waveform, at omega t is equals to alpha, VAB is greater than 0. Means anode to cathode voltage of thyristor T1 and T2 is greater than 0. So both conditions to turn on the thyristor are satisfied now. Means anode to cathode voltage is greater than 0 and gate pulse is applied. So T1 and T2 get turn on and they will start acting as short circuit. As soon as T1 and T2 get turn on, then immediately output current I0 gets shifted from T3, T4 to T1 and T2. So current through T3, T4 becomes 0 and they will act as open circuit. Now we can redraw the circuit like this. New path of current I0 will be like this from Vs to T1, then to load and then to T2. Okay, now we can see in waveform after omega t is equals to pi, polarity of source voltage, that is VAB, becomes negative. Means VAB is less than 0 and T1, T2 get reverse bias. But still T1, T2 continue to conduct until and unless these thyristor T3 and T4 are fired again. This is because of highly inductive load which makes output current nearly constant. This I0 keeps current through T1 and T2 greater than their holding current. That's why these thyristor will continue to conduct. Now we will find the parameters. First see the loop containing source voltage Vs, T1, load and T2. On applying KVL in this loop, we get VAB is equals to V0 and that is equals to Vm sin omega t. See the waveform of V0. Here from alpha to pi plus alpha, VAB appears across output. Okay. Now we know that thyristor T3 and T4 having current I3 and I4 are open circuit. Okay, so we can write IT3 and IT4 is equals to 0 and also we can clearly see that IT2 is equals to IT1, that is equals to I0. In the waveform we can see that from alpha to pi plus alpha, IT3 and IT4 is equals to 0 and IT2 and IT1 is equals to I0. Now we know that drop across sorted thyristors T1 and T2 is 0. So we can write VT1 is equals to VT2, that is equals to 0. We can also clearly see this in waveform. So, okay, now apply KVL in the loop containing Vs, T1 and T3. So on applying KVL, we get VT3 is equals to minus Vs and that is equals to VBA and that is equals to minus Vm sin omega t. Similarly, applying KVL in the loop containing Vs, T2 and T4, we again get VT4 is equals to VBA. See the waveform of VT4, VT3. Here, VBA will appear across T3 and T4 from alpha to pi plus alpha. Let's start the circuit operation from pi plus alpha to 2 pi plus alpha. At omega t is equals to pi plus alpha, T3 and T4 are triggered, and we can see that at omega t is equals to pi plus alpha, VBA is greater than 0. So T3, T4 will get turned on and act as short circuit. As soon as T3, T4 gets shorted, the current I0 will shift from T1, T2 to T3 and T4. So the current through T1, T2 becomes 0 and they get turned off, or we can say that they becomes open circuited. The circuit will look like this. A new path of current will be from Vs, T3 load and then to T4. In this way cycle continues. Now we will find the parameters from pi plus alpha to 2 pi plus alpha. Here apply KVL in loop having Vs, T3, V0 and T4. We get output voltage is equals to VBA and that is equals to minus Vs. Thyristor T1, T2 are off. So we can write IT1 is equals to IT2 and that is equals to 0. Thyristor T3 and T4 are short circuited. So we can write VT3 is equals to VT4 and that is equals to 0. We can also clearly see that IT3 and IT4, the current through them is equals to minus I0. Okay. Now, if we apply KVL in the loop containing T1, T3 and Vs, we get Vt1 is equals to Vs. And if we apply KVL in the loop containing Vs, T4, T2, then we get Vt2 is equals to Vs. Now see the waveform. See, V0 is equals to VBA. So VBA will be appear across load. I0 is constant. Is is equals to minus I0 from pi to 2 pi plus alpha. Now IT1 and IT2 as both are in off state, that's why IT1 is equals to IT2 and that is equals to 0. Now see VT1, VT2. Here the waveform of Vs will appear across VT1 and VT2. Now see the VT3 and VT4, both are in on state, that's why drop across them is equals to 0. So this is first part of lecture number 25 and I hope you all understand the concept. Thank you. Jai Shri Ram.